Yes, ma'am.
Yeah, thank you. So today is the fourth day, that is second last day of this FDP. And today's agenda, I'm going to talk about analysis of variance, that is ANOVA, right? So I'll just share my screen with all of you. Okay, my screen is visible.
Yes.
Fine. Okay, so I think till the date, what we have done, we have understood the concept of descriptive statistics. We have understood the how we can perform descriptive statistics using Excel. Then we have understood the concept of non-parametric test, and in that category, we have seen chi-square test. Yesterday, I talked about the parametric test, and I talked about the t-test, right? Now, we are talking about the next test, that is the analysis of variance, which is the another parametric test, right? So agenda is ANOVA, that is analysis of variance, right? So analysis of variance, ANOVA, is a parametric test, right? That is one of the assumptions of ANOVA is also related to the normality. And apart from that, there will be the equality of variances assumption, outliers, etc. These are the some of the assumptions which generally researcher can check before performing the ANOVA test. Now, when I talk about ANOVA, ANOVA is the analysis of variance, that is, it is also used for finding the mean difference. I think yesterday when I talked about t-test, I said t-test is used for finding the mean difference. So in the same way, ANOVA is also there for finding the mean difference. Means ANOVA and T is working or doing the same thing for us. But when I talk about ANOVA, ANOVA is nothing but it is an extension of t-test. Right? So it is the enhanced version of the t-test. Yesterday we talked about, especially when I talk about the independent samples t-test. So I think you can write it like it is the extension of independent samples t-test. Right? So can anyone tell me what independent samples t-test does for us? Anyone?
Ma'am, it tries to compare the mean of two independent samples.
Very good. Thank you so
That is
much,
the mean
ma'am.
of.
Yes, Seema, you are very correct. It is helping us to compare the mean of two groups or two samples, right? So we can say when I'm having two groups or two samples, I can compare their means using the independent samples t-test. Question comes if what if I'm having more than two samples available, right? That means capacity of independent samples t-test is only to compare the two groups for their means. And if you are having more than two groups available for your variable, in that case, t-test cannot be applicable there, or t-test cannot do that. It cannot compare more than two groups simultaneously. If you want to compare two or more than two groups simultaneously for the mean, you can use the ANOVA test, right? So I can write here that it is helping you to compare means of more than two groups simultaneously, right? So when you are having more than two groups available with you, you are using ANOVA, right? I think concept is clear. When we are using ANOVA we are using when we want to compare the mean, and especially the mean of more than two groups, right?
Ma'am, ANOVA is not analysis of variance.
It is analysis of variance. ANOVA stands for analysis of variance. That means when we are talking about analysis, when we are talking about ANOVA, that means we are talking about the difference in the variance of mean.
Okay.
Right? So that way we can say it is ANOVA. ANOVA is having a concept of between and within. If you have seen the performance or the output of ANOVA, we are knowing this thing in the output table. We are getting between groups, within groups, right? So we are checking whether the within group variance and between group variance, we need to compare these variances, right, in the mean.
Okay.
Fine. So that way it is ANOVA. Now next comes requirement. So requirement of ANOVA is depending upon the types of ANOVA. So we will say what are the various types. First one is the one-way ANOVA. Second one is two-way ANOVA. Right? One-way ANOVA and two-way ANOVA. These are the two types of ANOVA available with us. And using that, we need to perform ANOVA using Excel or whatever software. Firstly, if I talk about one-way ANOVA, what is one-way ANOVA? So it is, I am writing here. Yeah. So when I say one-way ANOVA, it is helping us to compare the mean of more than two groups for it is helping us to compare the mean of more than two groups for any variable. That is any numeric variable. Right? So if I say the variable requirement for one-way ANOVA, I think this will give you a better picture or understanding. This will say we will be having one IV and one EV. IV is independent variable, so we need to have one categorical variable with minimum 3 groups or categories. Right? And dependent variable will be the numeric variable or continuous variable. You can call it as interval or ratio scale variable. Right? So you can see similarity in the requirement of the variable is very same as independent sample t-test. Yesterday also I told you need to have two variables to perform independent sample t-test. One variable will be the numeric variable and one variable will be the categorical variable. Only difference coming here, that is categorical variable can have more than two groups available, right? If you are having more than two groups and if you wish to compare the means of all the groups together, that is simultaneously, you can use the ANOVA, that is especially one-way ANOVA. I hope it is clear. Is it clear, friends?
Yes, ma'am. Yes.
Fine. So, hypothesis will be here. There is no significant difference in the mean of EV in various groups of IV. Right? So suppose I am measuring the weight of 3 different groups, right? Or I'm having the weight of 3 different groups. So I can compare their mean, compare the mean weight of different groups. So that way I can say I'll go for performing the ANOVA. Is it clear? Marks of 3 sections. I'll go for the ANOVA. Salaries of 3 different departments or 3 different companies. I'll go for ANOVA. Is it clear?
Yes.
Fine. Now we'll go for the next type of ANOVA, which is one-way ANOVA. Sorry, which is two-way ANOVA. So two-way ANOVA meaning is I'm having 2 categorical variables, right? Two-way meaning here you need to make a means I already explained you the concept of cross tabulation or contingency tables. When I'm talking about two-way ANOVA, I'm saying it is like you will be having two-way division of the data. That means one way will be the one categorical variable and other will be the other categorical variable. One variable will be in the row, one variable will be in the column, right? So that way you can say, and you will be having the value of numeric variable for that. So that way you can say you are going to perform two-way ANOVA. Purpose here again to compare mean. Purpose is simple. You need to always compare mean in case of ANOVA, right? But when I say this is two-way ANOVA, so here you need to understand the concept is you need to have variables, that is 2 IV, 2 IVs and 1 DV. IVs will be categorical and DV will be numeric, that is interval or ratio scale, right? So one means when I'm having more 2 categorical variable, I'm having 1 dependent variable. I want to see whether this dependent variable having the same mean in context to the 2 categorical variable or not, right? So this way it is known as two-way ANOVA. We are comparing the mean of numeric variable in the combination of 2 categorical variable, right? Is it clear, the concept of two-way ANOVA? Is it clear, friends?
Ma'am, can you give an example of two-way ANOVA?
Okay, say for example, I want to compare the marks of students on the basis of their sections and on the basis of their gender.
Okay.
So gender-wise and section-wise, I want to compare the marks. So I'm considering both the categorical variable and want to see whether the difference is coming in the marks or not. Right?
Okay. Okay.
For example, so before that, I'm telling you the hypothesis, right? So when you're talking about two-way ANOVA, generally you need to have, I think till now we have seen when we are talking about one-way ANOVA, we have talked about independent samples, paired sample, one sample. Even in chi-square, both the cases we have seen, we need to only formulate one null hypothesis. But in case of two-way ANOVA, you need to either formulate 2 null hypotheses or 3 null hypotheses, which is depending upon, again, the types of two-way ANOVA. Means further two-way ANOVA can be bifurcated into the 2 more categories, that is with replication and without replication. So these are the further 2 more classification of two-way ANOVA, with replication and without replication, right? So wherever you're replicating the categories of one of the independent variables, there you are going for the with replication case. But when you are not, what I can say, wherever you are not replicating the categories of the independent variables, in that case you can go, it is a case of without replication. I think in the upcoming sheets you can see the example. So we will discuss with replication, without replication, using those examples, so that will give you the better picture. But I need to mention here, when you are talking about the with replication case, you need to make total 3 null hypotheses. So total 3 H0 you need to create in case of with replication, and 2 null hypotheses you will create in case of without replication, right? So that way I'll tell you further. how you will formulate the null and 2 or 3 null hypothesis in case of with and without replication. So with replication meaning is, say for example, I am having gender, I am having the section. So section 1, 2, and 3. And now when I am replicating gender, that means I have taken the 10 female and suppose 10 males. So that means I am replicating, I'm repeating the categories, or I'm repeating the respondents in that category. It is known as replication case. But if suppose I'm talking about, suppose I am having the 5 treatments, and which I'm giving to the suppose 5 treatment means suppose 3 therapy I'm having, therapy 1, therapy 2, and therapy 3 I'm having, right? And suppose I'm having their gender of not gender, maybe I can take a variable like medical terms. If I'm talking about therapy, second variable, if suppose I am taking as what will be the better example here of second variable?
Learning counseling.
Sorry,
It can be
Learning
age group.
counseling.
not getting.
Learning counseling, like this is how you should study and all that. Maybe we can consider that as therapy, ma'am.
That is therapy, ma'am. I am talking about the second variable. I need to take the second variable here. I don't want to
What
take
about
gender.
age group?
I don't want to take that.
Oh, ma'am, with the help of AI, without help of AI.
That we can do with the help of AI, with the help of without help. But meaning is that when I'm talking about without replication, you need to understand what I'm saying. I'm saying I'm not replicating. So that means suppose I have written here with AI and without AI I have written, and I have written here therapy 1, therapy 2, therapy 3. So I need to see how many of the students have got the therapy with AI, that is therapy 1, similarly therapy 2, therapy 3, and likewise for the without AI 3 therapies. So in that case, I'm not replicating, I'm not repeating any of the categories of my categorical variable. It is a without replication case. But when I'm replicating means I'm repeating that category again and again. Let's say, for example, I'm having a male and female category. I'm repeating male, 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 female, 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 female. That is our replication case, right? So in case of replication, you need to make total 3 null hypothesis. In case of without replication, you need to make only 2 null hypothesis. So here, suppose I'm writing, as I have given you the example of suppose marks, gender, and section, right? So in this case, my first null hypothesis, that is H0, will be based on marks and gender. My second null hypothesis will be based on marks and section. My third null hypothesis will be based on marks, gender, and section. Is it clear? This is a replication case. Sorry, without replication case. Sorry, with replication case. I was correct previously. It is with replication case, right? In with replication, you need to formulate total 3 null hypotheses. Fine. Fine. In case of without replication, suppose I said what I said, training type, no treatment type.
Treatment type, ma'am. Therapy, you said.
Yeah, therapy or treatment, therapy type or treatment type, whatever you want to write, you can get, right? And with AI or without, right? Means insertion is okay, and performance or maybe score, right? So where you're not replicating your variables or categories of your variable, you will go for only 2 null hypotheses. That is H01, you will write score and treatment type. Second, you will write score and insertion. Right? Is it okay, clear? Shall I go ahead? Am I audible? I hope, right?
Ma'am, why it is not a score, treatment, and
Because here
insertion type?
there is because here there is no interaction effect. When you are talking about replication, there will be the main effect and interaction effect. So in case of with replication, it is possible when you are repeating the categorical variable categories, but here you are not repeating these categories. So here only possible for you to see the main effect of variable. That means here we are looking the main effect of gender on marks, main effect of section on marks, and these are the interaction effect we are looking on the marks. Means simultaneously whether the section and the type or the gender impacting the marks of student or not. But in the case of without replication, where replication is not made by us, here only possible to see the main effect. Main effect, that is whether the treatment type is making the impact on the score, improvement score of the student or not, or maybe when you are providing the insertion of AI in the treatment, whether it is impacting the score of the student or not. Is it okay?
Ma'am, not clear, but we will go ahead with this.
Why, ma'am?
Ma'am, when we are talking about the insertion of AI, we are saying we are not replicating the category, right? But insertion of AI is again replication of the category, whether it is there or not there.
It is not a replication, it is only the categories of that variable, ma'am. I think you are not
That
getting
is
the
what
point.
I'm saying.
Suppose here I have written for AI, suppose it is written yes, for not it is written no, right? And here I have written the treatment, suppose training type or therapy type T1, then T2, and then suppose T3. So I'm having only the scores available. Yes, how many?
Okay.
Right, so there is no replication. I'm not saying I have performed yes or yes is coming many times. It is not coming many times. It is only coming one time. I'm not repeating these categories. Whereas here I am telling you, when I'm telling you this, I'm telling you I'm having the suppose
Okay. Got the point.
section 1,
Got the point. Got
section 2, section 3, and then here I'm writing I'm having male, not one male, more than one male students I'm having. Like that, similarly female I'm repeating. So here if there is a replication in one of the categories of your categorical variable, so that is why you are able to see the interaction effect. Here you are not replicating them, so we are only looking for the main effect of the variable.
Yes, got the point.
Okay. So this is about the conceptual aspect of ANOVA. If it is clear, shall I go for performing ANOVA using Excel?
Yes, ma'am.
Fine. Expecting you, I think I already shared the sheet with all of you. Please open the sheet. Sheet number 1, you need to open, which is named as one way. Done?
Yes.
Fine. So here I'll talk about, we are having the strength of tapes which we are receiving from the 3 different suppliers, supplier 1, 2, and 3. So these are the tape strengths given for from the 3 different suppliers. So can anyone tell me what type of or what number of variables are given and what is the type of variable here?
Ma'am, this is one way ANOVA.
No, I'm asking all the type of variables available with.
One is the numerical, one is the categorical.
I want to get the names using the example.
Acha, okay.
in this question, what are the variables given and what are the types of those variables?
One variable is strength of tape and another is supplier, tape supplier.
Very good. Strength of tape is the one variable. Second one is the type of supplier. Fine? Fine? Everyone, it is okay?
Yes, ma'am.
What is the type of strength of tape variable? On what scale we have measured it?
It is not written there.
Okay, fine, no issues. And what about the second?
Ma'am, type of supplier is the categorical variable.
Very
Independent.
good. It is categorical variable. Very correct. Thank you. The strength of the tape is nothing but these are the values which are given. Means whatever the tapes we have supplied or we have received from the supplier one, we have measured their strength and these are the strength mentioned here. All these are the strengths and nothing else. So what is the scale of this? It is numeric. It is continuous variable. Yes or no?
Yes,
Yeah.
ma'am.
Right? So that way you can see, according to the variable requirement, we are having one numeric variable, one categorical variable, and here we are having total how many categories? 3. Yes or no? 3 suppliers I am having, right? Yes,
Yes,
or
ma'am.
no?
Yes, ma'am.
Now, if suppose I want to compare the mean strength of the tapes which we have received from the 3 different suppliers, so that means as I need to compare the mean strength, right? So I can go for the t-test here, but thing is here we are having more than 2 suppliers available. That means I cannot go for the independent sample t-test. I should go for one-way ANOVA because I'm having one categorical and one numeric variable. Is it okay?
Yes. Yes.
Fine. Fine. So now we will write our null hypothesis. Anyone who can try?
There is no significant difference in the mean. Oh, okay. We have to form 3 null hypotheses.
No. It is one-way ANOVA. In case of one-way ANOVA,
Okay, one. Okay. So there's no significant difference in the mean of strength of tape of different supply.
okay, there's no significant difference in the mean strength of tapes received from right? Fine. Fine.
Yes, ma'am.
Fine. So we have written our null hypothesis here. And now I think according to the data requirement, we are very clear we should go for one-way ANOVA. So expecting everyone to explore this data tab, data menu, and open the data analysis toolbar. Now you can see as alphabetically tests are listed here. So initially we can find ANOVA. ANOVA single factor is written here. Yes. So single factor meaning is single independent variable. Factor meaning is generally independent variable. In terms of research or statistics, factor is here the independent variable, right? Fine.
Yes, ma'am.
Fine. So click on this. Is it fine? Can I go ahead? Everyone has got this dialog box?
Yes.
Yes.
So select your entire set of data. I have selected my data including the headings or labels of my column. So my range is A2:C32. You please check, you people have also done this.
Yes.
Done. Now you can see it is asking you grouped by columns or rows, means whatever range you have selected here, this range is in grouped by rows or columns. So you can see our data is in the column. First supply data in one column, second in the second column, third in the third column. It is by default in the columns. So we will not go with this. If your data is listed like in the rows, in that case we will go with the rows. Right? So we will go with the by default option here. Now labels are already I selected, so I'm selecting this checkbox. Alpha, that is level of significance, by default is 5%. I'll okay with it. I'm not changing it. Then output options, I think we will up to you, means I'm going with the first one. And then I'm selecting a blank cell where I'll want to get my output. So I think it is all. So I'm all set for the getting the output. So shall I go ahead with okay?
Ma'am, once please repeat that row and column wali selection, ma'am.
Miss, I need to tell you how to select this. This is what you are saying.
Select based on row, based on column.
Data
please
is in the column, so we will go with the columns. But if data is listed like in the rows, we will go with
okay.
the row, right?
Okay, ma'am. Thank you.
Yeah. Anything else? Shall I go with the okay?
Yes, ma'am.
Yeah.
Ma'am, I did not find data analysis in my row and my laptop.
This is the first session for you, ma'am.
No, ma'am.
You have initially added it.
Okay, ma'am.
Have you added the add-ins in your laptop, ma'am? In the Microsoft of in Excel? Have you added it previously?
Yes, ma'am.
Okay, so means previously you were able to got all the outputs which we have performed.
Yes, ma'am.
Okay, so maybe ma'am it happens sometimes. Either you can close your Excel, open it again, and then explore. If it is not coming, you can go and repeat the process. Go to the file, then options, add-ins. Same process you need to repeat again.
Okay, ma'am.
So you do, and then tell me, are you getting it or not? So do I need to wait for you? I think it will take only few seconds to repeat the process.
Yes,
Fine.
ma'am. No.
Now you are getting?
Few seconds, ma'am.
Okay.
Madam, did you click on edit PDF option, that yellow button? वो PDF edit
Yes,
नहीं
ma'am.
हुआ तो if it's not
Enable editing.
एडिटिंग कर दिया है मैंने, बट ये शो नहीं हो रहा है डेटा एनालिसिस इसके अंदर.
आप डेटा पे जाइए, डेटा पे जाके इट्स एट द लास्ट बटन है, लास्ट वाली डेटा एनालिसिस होगी उधर, आप डेटा पे जाके देख लीजिए.
नो मैम, ये नहीं है, इसमें शो नहीं हो रहा है.
आपका ये एंड्रॉइड है, नहीं तो मैकबुक है?
मैम लैपटॉप पे है.
नहीं, एंड्रॉइड और मैकबुक, ये एप्पल वाली और नॉर्मल वाली.
What is the brand? Means whether you're using HP.
नॉर्मल मैम, नॉर्मल ही है.
Sometimes it happens with the analysis toolpath, ma'am. So that is why I told you to repeat the process. Go to the file, then options, then add-ins, then go button, then select that checkbox, first checkbox, and then click on OK. And then tell me, is it now working or not? Have you done the
मैम
process?
डेटा एनालिसिस ही शो नहीं हो रहा है, तो फिर वर्किंग कैसे करेगा?
I'm telling you to add it again.
Excel 6 is installed or not?
मैडम व्हाई डोंट यू गो अहेड विद द लेसन वो टुडे एनोवा मैडम आपका कुछ भी डाउट्स है आप क्लास के बाद प्लीज पिंग मी ऑन व्हाट्सएप वो शालू है ना शालू वाली व्हाट्सएप में आप पिंग कीजिए मैं आपके साथ बता दूंगी
Okay, ma'am. Okay.
मैम आप
Go
हाँ यस
ahead.
मैम मैम मैं प्रोसीड मैम
Fine. So click on OK now. After selecting the location of your output, click on OK. So once you're clicking on OK, I think you got the output. Everyone has got it?
Yes, ma'am.
Fine. So I'll go for the interpretation now. You can see, firstly, we are getting a summary table, right? In the summary table, you can see we are having the 3 suppliers listed here. We are having the 3 groups of 3 suppliers, right? Per supplier, we are having 30 observations. Then it is the sum of tape strength from whatever 30 tapes we have taken of the supplier 1, or whatever the strength of the tapes given to us, we have added them. So this is the sum of the tape strength. This is the average tape strength. This is the variance in the tape strength, which we have received from the supplier 1. Likewise, you can read for the remaining suppliers. Next table is the ANOVA table, which is very important for us, which is we need to report usually in our research work, right? So there you can find we are having source of variation, means that why ANOVA stands for analysis of variance. So thus variance which is coming in the mean, which is coming because of 2 reasons. First reason is the between groups. Second reason is the between groups, right? Now you can see we are having supplier 1, 2, and 3. That means it is between. When I compare the mean between these suppliers, right? That is between suppliers or between suppliers, the variance is coming in the tape strength. Similarly, when I say within group meaning is means from the same supplier, whatever the tapes I have received, even in that there is a variance available. So that is known as within group variance. Is it okay? Now, coming to the next column, which is the sum of squares. Usually it is nothing, because when we are talking about the calculation of variance is nothing but it is generally the, suppose I'm having a series X. If I will calculate the variance, it is X minus X square, summation of X minus X square divided by N, right? So that is why it is coming or named it like sum of squares, right? So between the group sum of square, within the group sum of squares are here. Degrees of freedom is n minus 1 in case of between groups, that is n minus 1. So how many groups we are having? We are having total 3 groups, group 1, 2, and 3. So it is n minus 1, which is 2. Within group is what? Within group is total number of observations, that is n, minus number of groups, that is k. So I am having total 3 groups. So it is n minus k. So total observations are 30, 30, 30. That is 90. 90 minus 3, which is 87. And then the sum of this 2 plus 87 is coming as 89. Then mean sum of square. So mean is always the average. So we will divide the sum of square by its respective degrees of freedom. It will provide me the mean sum of squares. And then I'll take the ratio of these mean squares, which will provide me the F value. Suppose I can write this divided by this, which is coming as 13.1885, right? Fine.
Yes, ma'am. Yes, ma'am.
So now further, we are getting the p value. So this is the p value and this is the critical value. So I think we are generally using the p value approach for accepting or rejecting a null hypothesis. So in our case, it is coming as 9.9 e minus 0.6. So it is 9.9 e minus 0.6, which is less than 0.05. That means we need to reject the null hypothesis. Done? Is it clear? So if I'm rejecting the null hypothesis, that means I will conclude there is a significant difference in the mean strength of tapes received from the three suppliers, right?
Ma'am, could you please repeat? Could you please repeat the same?
From where?
Then
ma'am,
P value.
Okay.
ma'am, but p value is more than 0.05. So
It is not more than, it is 9.9 E minus n E minus 0.6. Meaning is that I don't know if it will give me that. No, it is not giving that. Meaning is that, okay, maybe just a minute.
Madam, E minus 0.6 matlab into 10 to the power of minus.
Yeah, I know it. I need to only show to the ma'am. I know it.
No, ma'am, I'm not telling to you for others. I
Okay.
also thought when I first did this, Anubha, oh my God, E kya hai mere baap.
You can
Sorry.
see
That's
what
what
you
I
did.
thought.
No, fine, it is fine. What I did, as you can see, this value is coming as a scientific value. So in the home tab, under the number, what I did, I have made it as a number. So that way also you can do. If not, what you can understand this, it is nothing, but it is E minus means it is exponential. It is 10 to the power minus 6, right? If it is E plus 0.6, it is 10 to the power plus 6. So it is 9.94 into 10 to the power minus 6. So that means it is a very small figure. It is 9.94 divided by 10 to the power 6.
Okay, thank you.
So it is a very small figure. So that is why we can say we are going to reject the null hypothesis and concluding that there is a significant difference in the mean strength of tapes received from three suppliers. Now it is okay.
yes, ma'am, understood.
Fine.
Now, one question, like
Yeah.
in independent t-test sample, we can have different sample. Means like we have seen there were more male than female. In this also we can have the different sample. Like under supply when we have 10 value, up under supply 2 we have 8 values. And
Yeah.
okay.
All possible, there can be, but usually means what I can say, we need to maintain uniformity because it will be like what I can say, unfair, no? If I'm having suppose 30 values here in the first group, 10 values in the second group, and suppose 5 values in the third group. So it is unfair way of calculating these things. So we need to maintain this thing. Usually it is difficult for us. Say, for example, I'm having, because this is the example I've already provided you. Once you are collecting the data, suppose I'm having, or I want to compare the salaries on the basis of occupation, right? So salary data I can easily ask from the person. Occupation I'm taking, suppose the business class people, maybe the service, or other, maybe suppose any profession. Right? Fine.
Yes, sir.
So now it is up to us. Suppose because it is like collecting the data, it is a primary studies, right? So primary data means you will go on field, or maybe you're circulating your Google form or something to the people for collecting the data. So it's not like always you are getting same proportion in these three categories, but you have to, or you need to try to maintain that ratio or proportion, right? That means suppose you are taking, suppose from 18 people here, suppose 22 from here, and suppose 17 from here. In that way, it is also little okay, or it is okay. But if it is like I am having only 10 business class people data, 30 this I have taken, and suppose this is I have taken 14 or something. So in that case, there is disparity. So you need to be little cautious while you are collecting the data.
Ma'am, in that situation, what shall we do? Because when we collect the data, this disparity comes.
It is coming because we are circulating the data, or we are collecting the data through the Google form. So whosoever is filling it is okay for us. But when we will go or involved in the basis of me, suppose you're going on field or directly you're collecting the data. So in that case, you're knowing that person is a businessman, or he or she is that particular person, because these things are leading to the problem of normality also. So that is why you have to cautious, or once you are collecting data, you need to see the proportion, and accordingly, then you need to circulate your Google form to those persons, those who are belonging to the other category, so that you can able to maintain that proportion.
Okay, ma'am.
Right. So
Okay.
that is why data collection is a very, very crucial task. And the method we are using to collect the data is also a very, very, very tough task.
Yes, ma'am. Most of the people do not fill the Google form.
Yes, people are not filling, ma'am. Apart from that, non-sampling errors are coming, like people are even filling for us. Maybe we are having a good relations with them. So what they are doing, they are filling for us, but they're not reading what we are asking from them.
Yes, ma'am.
There are so many problems. Even people are not knowing the meaning what we are asking to them. Suppose they are reading even, so maybe there is some technical terms, they're not knowing the meaning of those. Even then, they are responding to your questionnaire. They are not aware about what we are asking. Even then, they are responding. So there are so many things. These things are leading to the problems in the conclusions, or maybe you're not getting the correct output because of these all sampling and non-sampling errors.
Yes, ma'am. That's why I try to work on secondary data.
Yeah. That is why people are nowadays doing the bibliometric analysis. People are going for the SLR and all. So there are various techniques nowadays coming. People are going for the qualitative analysis. People are doing the interviews and trying to do the qualitative analysis using those interviews and all. So nowadays things are so many available, and people are trying to do or trying to contribute to the society so that some good results can be obtained by them, which can help the society to grow. Right?
Ma'am, for qualitative analysis also we can, there are other softwares, madam.
Softwares
Oh.
are available.
Okay, ma'am.
Yeah. So I think one way ANOVA is clear to everyone.
Yes, ma'am.
Fine.
Yes, ma'am.
Second sheet is for the practice sheet of one way ANOVA. You can do by your own. Coming to the with replication case now. Open the sheet named as with replication. Open.
Yes, ma'am.
Fine. Now you can see same example in the extended form I have given to you. Strength of tapes is given to us. Type of suppliers given to us. Along with that, one more column added, that is the box type. So you can see total 2 box types are given in type 1 and type 2. So how many variables now I'm having?
1, 2, 3, 4, 5, 5, 1, 5,
Three.
ma'am.
3 variables we are having. First is the type of box. Second is the type of supplier. Supplier name, and third is the strength of tape.
Very good. Now I am having 3 variables, 2 categorical, box type and supplier type, and one is the strength of the tapes. So strength of the tape is this. In the combination now you can see combination is supplier 1, type 1. Means from supplier 1 I received 2 boxes, type 1 and type 2. So in that box, whatever is the tape I am having, this is the strength. So in that box, there can be so many different types of tapes available. So I have taken the different tape from the same box and I'm measuring its strength. Clear? Similarly from the box type 2. Okay. Done?
Yes, ma'am.
Now,
Okay, ma'am.
yeah. So now you can see this is a replication case. Box type is one of the categorical variables where the categories are replicating, that is repeating. You are repeating type 1 up to some number of times. Similarly, type 2 is also repeating for some number of times. So there is a replication, that is why it is a replication case. And in case of replication, how many hypotheses we need to formulate?
3, ma'am. 3.
Very good. Thank you. We will formulate total 3 hypotheses, right? So I'll remove all this and I'll write the hypothesis now. Fine. So hypothesis number 1 will be in combination of
Type 1, supplier 1,
Ma'am, it's strength and type of supplier, strength and type of box, and the third hypothesis includes all type of box, type of supplier, and strength.
It was Seema, ma'am?
Yes, ma'am.
Very correct. Thank you. Thank you so much,
Okay.
Seema, ma'am. You have made it very easier for me. Ma'am has said very correctly. Always, if you have seen when I was discussing the concept, that is of two ANOVA with replication case. You can see this is the example I have written here. You were having three variables available, and in all the three null hypotheses, you can find what was the common thing: marks. Yes or no? Right?
Yes.
That means your dependent variable, because a mean is possible only to calculate of your numeric variable. Mean we cannot calculate for the gender and section variable. Right? So always the center is your numeric variable. So in this case, my numeric variable is tape strength, right? So my first null hypothesis will say there is no significant difference in the mean tape strength due to type of suppliers, right? Done. Second will be there is no significant difference in the mean tape strength due to the type of
Box.
box. Third will be there is no significant difference in the mean tape strength due to the interaction effect.
So tape and type of box.
Done. Clear?
Yes, ma'am.
Done. So this way, these are the three null hypotheses we need to check. That means we need to have total how many p-values?
3.
3 p-values.
Ma'am, can you please explain last one, third null hypothesis one more time?
I said there is no significant difference in the mean tape strength due to the interaction effect, because I'm considering both simultaneously now. That is from which supplier I have taken and from which box type I have taken the tape. So in the combination of these two, I want to see whether when I'm combining both my categorical variables, so whether these are impacting my dependent variable or not. Whether it is making any change in the mean value of the dependent variable or not. Is it clear?
Yes, ma'am.
Fine.
Interaction effect of box and supplier.
Yeah. So now we will go to perform, go to the data type, analysis tool pack, and select the ANOVA 2 factor with replication, right? We'll click on OK. You can see in this, firstly it is asking me for the range of my data. But in the next, it is talking about rows per sample. Rows per sample meaning is whatever the variable I have taken in the row, categorical variable I have taken in the row, in that how many sample per row available, right? Sample per row meaning is whatever the categories I'm having in that category, how many time I'm replicating it, right? I need to see them. So I will select this type 1. It is coming till here. Now you can see it is indicating 15 rows, right? For type 1 means first sample is type 1. It is having total 15 rows. Similarly, I need to check for type 2 also. Type 2 is also 15. Done?
Mhm.
Check everyone.
Okay, ma'am. Okay.
We will go to the analysis tool pack now. Again, I'll select the ANOVA 2 factor with replication and click on OK. So now, firstly, I'm providing the range. I selected the range. Done. Rows per sample. How many rows I was having? 15. So you need to see here now. It is very important and imperative to understand that whatever a number of times I'm replicating first sample or first category, for the same number of time I need to repeat or replicate the second sample also, because I'm having only one box available. It is not like for sample 1 different number of rows I can pass, or sample 2 different number of rows I can pass. Is it okay? So that is why you need to maintain same replication for both the samples. Is it clear?
Mm.
So now further, alpha is by default 0.05. We will go with this. Now output, I'll select this and I'll generate my output.
मैम आपका वॉइस नहीं आ रहा है. We can't hear your voice. We cannot see your screen.
Yeah, sorry, ma'am. I have muted.
Okay, okay. Okay. I thought it's.
Talking to someone at my home.
Okay. Yes, ma'am. Sure, sure.
Yeah. So select the output range. I selected this cell. Click on OK. So shall I go for OK?
Yes, ma'am.
Yeah. So I think we got the output. Shall I go for interpretation of it? Everyone has got the same. Shall I go?
Yes, ma'am.
Fine. You can see, firstly, I'm getting a summary table. Right? In the summary table, you can find I'm having the type 1 and type 2 and then total. These are the 3 different tables I'm getting. That is, firstly, it is considered your sample type 1. Right? Count is 15, 15, 15. Right? Sum is sum of the strength when I'm talking about the first type of box. Right? That means from the first supply, 15 observations for the type 1, from the second supplier, 15 observations for the type 1, from the second supplier, 15 observations for the type 1. These are the tape of strength for those 15 samples. This is for the, again, the sum of the tape strength for the remaining 2 different suppliers, right? This
ma'am,
is the,
ma'am,
yeah.
Can you please tell me, वो input range एक बार बोल दीजिए ना?
Okay. It was A2:D32.
To say. Oh. Okay, ma'am. Sub. The whole thing. Oh.
Sorry.
8 minutes, ma'am.
Yeah.
Ma'am, this limitation of same number of rows for type 1 and type 2, is it a limitation of Excel or it should be?
No, it is there in SPSS also.
Okay, SPSS.
मैम ये बोल रहे कि ये एक्सेल बोल रहे कि 2 factor with replication input range should contain 2 or more blocks of data arranged in rows or columns.
You need to
After
select your data including the labels. I hope you selected your data including the labels, headings.
Yes, ma'am.
Then how it is coming? Range is A2:D32.
Yes, ma'am. मगर
Hmm.
वो इधर here in my laptop it is not showing labels, so
Labels
label.
also not there in our case also, ma'am.
Oh no.
In my
Maybe
case,
not.
label option is not available.
Madam, I will watch this YouTube again. You go ahead.
Okay. I'm repeating output in output range is A2:D32. rows per sample is 15. Alpha I have taken 0.05, and output range I have selected F3. I don't know where you have selected, and click on OK. That's all.
Maybe I also did the same thing, ma'am.
Possible for you to share the screen?
I'll you, madam.
So how you are managing, ma'am? What you are showing me image of what you are showing to me?
Video. I just put video, ma'am, just now.
Where?
वो WhatsApp पे. Ma'am, others are and the other ma'ams also got output. Only I am getting like this.
I think I don't know that, ma'am. I will need to ask from the people.
Ma'am, you have selected B32. It is not B32. It is D. D for Delhi.
Oh. Okay. Oh, thank you, madam.
Welcome, ma'am.
The complete data you need to select, ma'am.
Okay, ma'am.
Yeah. Okay, so we will go and talk about further. Further, you are getting the average mean strength from all the three suppliers for type 1. Similarly, variance in the tape strength for all the three suppliers from for type 1. Similarly, you can read the second table for type 2 box, right? Next one is combination of both. That means irrespective of type 1, type 2, only you are considering 30 observations, and you are getting the sum, that is tape strength sum, average and its variance, right? Coming to the next table, which is the ANOVA table. So I think I can go for this now.
Yes, ma'am.
You can see source of variation will be the sample, columns, and interaction, right? And then within. So these are the three common, four variations which can come, or four way there can be the variation or variance can come there in the mean, sample, columns. Sample meaning whatever you are taking in the row, then column, that is box type, type of what I can say, the supplier, interaction of both of these two categorical variable, and within. So that way you can find these are the four variations. Then sum of squares is coming. Degrees of freedom is coming. So we are having how many samples? 2. Box type 1, box type 2. So it is n-1, which is 1. Columns, we are having total 3 variety. So it is 3-1, which is 2. Interaction is coming only 2 of your variables, and within will be 84. Mean sum of square will be nothing, but it is the division of your SS by the degrees of freedom, which will give you the mean sum of square. Coming to the F value, if I need to tell you how to calculate it, how it is coming, you need to divide it like 10 divided by 0.9178. Similarly, 4 divided by 0.91786. And similarly, 1.28 divided by 0.19786. That means within will be always coming in the denominator part, and that way you will get the F value, right? Then P values are listed here. So on the basis of P value approach, if you want to accept or reject the null hypothesis, you can see this P value is less than 0.05. This is also less than 0.05, and this is also less than 0.05. That means all the three null hypotheses we are rejecting in our case. So what we are considering, or what we are concluding that there is a significant difference in the mean tape strength due to the type of suppliers, also due to the type of box, and also when you are considering both the categorical variable, these are making impact in the mean tape strength, right? Means whether you are changing your supplier, it is impacting the tape strength. Whether you are changing the box, it is impacting the tape strength. Whether you are considering both, means from this supplier, this particular box you have taken, so it is making impact on the tape strength, right?
Yes, ma'am.
Right. Now, This is about the two-way ANOVA with replication case. Next sheet is for the practice purpose, which you can do by your own. Last sheet is without replication. In the without replication sheet, you can see there is a problem given for all of you. I'm expecting you to please read it in a second, or sorry, in 5-10 seconds, you please read the problem. And then we will do the performance of the ANOVA on the problem. So read it. Fine. So we can say we are having problem says new fertilizer has been developed to increase the yield on crops.
Yes, ma'am.
The makers of the fertilizer want to better understand which of the three formulations, that is blends, of this fertilizer are most effective for wheat, corn, soya beans, and rice crops. They test each of the three blends on one sample of each of the 4 types of crops. The crop yields for the 12 combinations are shown below. So you can find here we are having the combination of, this is a grid given to us. In that you can find blend X, Y, and Z. And only one sample of wheat was taken, and on that blend X was performed, or on which the blend X was used. Similarly, on the second sample blend Y, and in the third blend Z was used. Similarly, it is for the it was for the wheat. Remaining is for the corn, soya, and rice. So that way you are looking here, you can see this is the grid or data given to us. I think I do not want to say much on this. I want to ask from you people, can you now identify how many variables are given in this particular problem and which are the variables according to this table?
I think fertilizer,
Yeah.
crop
Mhm.
type, and interaction between fertilizer and crop type. Correct, madam? Correct only? Wrong, ma'am.
Third variable I'm not getting. First one
First is fertilizer.
is correct.
Second is crop type.
Correct.
Third is interaction between fertilizer mixture and crop type yield.
Yield is the third.
Oh.
Right?
Okay.
Means when I'm using this blend X on wheat crop, what is the yield of the wheat? When I'm using blend Y on one of the sample of wheat, this is the yield. When I'm using third sample, third blend on the third sample of the wheat, this is the yield.
Okay, ma'am.
Right? So this way, again you can find two categorical and one numeric variable. That is type of blend, type of crop. These are the two categorical variable, and the yield of the crop is the third variable, which is numeric. Fine.
Numeric. Okay, ma'am.
Is it clear?
Yes, ma'am.
Fine. So we want to see, as this is a case of without replication, because you can see there is no replication. Only one sample of wheat was taken, only one time that blend X was used on them. So it is again an experimental kind of a study, right? You can see here we are only using one blend on one sample of the wheat. Similarly, second blend on the second sample of the wheat, and likewise. So that way there is no replication. I'm not repeating blend X multiple times here. Similarly, blend Y on multiple times, and likewise. So that way there is no replication coming here. So we will go only for formulating two null hypotheses. So what will be the combination? Can anyone tell me?
There is no effect of No effect of fertilizer blend on crop yield. First one.
Okay.
No effect of fertilizer blend on different types of crops.
Very good.
Second one.
Second one is repeat ma'am again.
No effect of fertilizer blending mixture on different types of crops.
No, second is not clear. Almost correct. First is correct. First you are saying no impact of blend on the crop yield of crop. Similarly, no impact of type of crop on the yield of crop. Always central focus will be on the yield, numeric variable. Always you can only compare the mean yield, no? How I can compare the mean of the type of crop or mean of the type of blend? That I cannot compare. I can only compare the mean yield. Production I can only compare, no? Yes?
Yes, ma'am.
We will write hypothesis. There is no significant difference in the mean yield of crops on the basis of type of blends, and there is no significant difference in the mean yield of crops on the basis of type of crops. Right? Because of type of crops, we are not monitoring or we are not observing any difference in the yield. Because of type of blend, we are not observing any of the difference in the yield. Is it clear?
It is not a mean yield of based on type of crop. Oh,
Okay.
okay, ma'am. Okay, ma'am.
Fine. Fine. Clear to everyone?
Ma'am, 1 minute, let me type it.
I'm waiting.
No impact. Ma'am, how you are typing so fast, madam?
I think this was written, ma'am. This is not I have typed. Previously, I have typed. This was written, so deliberately I have not removed it.
Oh.
If you say means my typing is little okay, means it is not that much slow and not very fast also, but it is okay. Because of teaching through the softwares, now I think I got that little good speed.
Basis of. Yes, ma'am, done.
Fine. So shall I go now?
Yes, ma'am.
Fine. So we will go to perform now the second variety of two-way ANOVA. So go to the data tab, go to the data analysis tool pack. Then click on the data analysis tool pack and select ANOVA two-factor without replication. Shall I click on OK?
Yes, ma'am.
Fine. Now the box is coming in front of you also. So you need to select the entire set of your data. Range is B5:F8, B to F, B, C, D, E, F. Okay. Labels, I select my data including the labels. I'm selecting it. Alpha is, that is level of significance, by default 5%. I'll go with this. And output I'll generate in the same sheet somewhere here. And I'll click on OK. So I think I can click on OK now. So may I?
Yes, ma'am.
Got it. You can see we are getting the output. Now I'll explain you the interpretation of it. Everyone who has got the output, shall I go for interpretation now?
Yes, ma'am.
Fine. Now you can see ANOVA two-factor without replication or output is coming for us. There you can find summary table is telling you it is according to the blend firstly. So how many blends I was having? 3 blends I was having, and per blend I am having total 4 values, right? So that is why it is count is 444. It is telling me the sum of yield, right? This is the average of the yield for the blend X. This is the variance in the yield because of blend X. So that way you can read the entire table. Coming to the this is according to the type of crop. So when I come to the type of crop, you can see per crop I'm having 333 observations, right? So that way you can see 333. Then this is showing me the type of, or this is showing me sum of yield. This is average sum of average yield. This is the variance in the yield for wheat. Similarly for the corn, soya, and rice, you can see. So this is the summary table we are getting. And lastly, we are getting the ANOVA table. So you can see here, ANOVA table is telling you there can be the 2 or 3 kind of variances or variations or source of variations, which is making changes in your mean, which is the rows, columns, and errors, right? So sum of a square, degrees of freedom, mean sum of a square, and then F value. I think we are knowing everything from the table now, and then we are having the P value. So when you will look at the P value, you can see the first P value is less than 0.05, but the second P value is greater than 0.05. So first P value is for the rows and second P value is for the columns. So in the rows, there was the blend, and in the columns, there was the crop. So we can say that is blend is making impact in the mean yield of crop, but type of crop is not making any impact in the yield of crop, right? Fine. So we can say hypothesis we are rejecting, but second hypothesis we need to go with, right? Is it clear?
Yes, ma'am. That means rows are making
The
significant
interpretation
difference.
which you told just now, based on the values which we got, the P value. Can you please
I need to
repeat the interpretation? Yeah.
I'm
What do we interpret from the
first
value?
P value, yeah, first P value is less than 0.05, but second P value is greater than 0.05. So according to the first P value, I need to reject the null hypothesis, but for the second P value, I need to hold my null hypothesis, right? So when I'm rejecting the first null hypothesis, I'm saying there is a significant difference in the mean yield of crop due to the type of blend. Second says there is no significant, because I'm accepting it, so I'm concluding the same that there is no significant difference in the mean yield of crop due to the type of crop. Means when you are talking about the variety of the crop, type of crop is not making change in the yield of crop, but when you are changing the blend, it is making impact in the change in the yield of crop. Is it clear? Fine. So this is about two-way ANOVA with replication. One thing I think I forgot to mention. So if everyone is okay with the concept, shall I go for that thing which I need to add? Fine. So I'll come to the one-way ANOVA first. You can see here, in case of one-way ANOVA, what we did, we have rejected our null hypothesis. Yes? So we have rejected our null hypothesis, means what we are concluding? We are concluding difference is there. The difference is significant. It is noticeable difference in the mean tape strength, right? Further, it is coming when the difference in the when the difference is coming in the mean tape strength. So in which pair that difference is significant? Now you can find here how many pairs are possible with the data. Supplier 1, 2, and 3. How many pairs I can make? Supplier 1 and 2 will be one pair. Supplier 2 and 3 will be the other pair. Supplier 3 and 1 will be the other pair. That means total 3 combinations are possible here, right? So the problem with the ANOVA is that ANOVA cannot go for the pairwise comparison. Once your null hypothesis is rejected, you can only conclude or you can only comment that there is a significant difference. But whether that difference is existing between the first pair or between the second pair or between the first and third pair or between all the pairs, that you cannot comment. Is it clear?
Yes, ma'am. Yes, ma'am.
That is the problem with the ANOVA. That means once your null hypothesis is rejected, pairwise comparison is not done, because ANOVA is able to tell you whether the significant difference is there or not. Means it is telling you simultaneous comparison, you can do that. Means suppose if I need to write my null hypothesis in the form of symbol, I can write it like this. That is mu1 equals to mu2 equals to mu3, right? Opposite to this, it is not equal to, means generally we are not writing it. We are writing like at least 1 mu is different. This is the way of writing the alternative hypothesis of ANOVA. That means at least 1 mu is different. right? Means if suppose I'm telling you that is mu1 and mu2 you are comparing, might be possible there is a significant difference existing, means you are getting mu1 is not equal to mu2. Further, it is not helping you to tell this thing that mu1 and mu3 is also different, or mu2 and mu3 is also different. Fine.
Okay, ma'am.
Got it. So that is the problem with the ANOVA, and further you can go for the pairwise comparison using the post hoc test known as multiple comparison, right? So that is not possible here in the Excel simple add-ins, that you cannot do. So you can confine your results till this only. Okay. Fine. So now I'm going for the conclusion of the session, and then I'll take your queries if you're having any. So friends, today we started with the another parametric test, which is ANOVA, analysis of variance, right? So I think we started that it is nothing but it is an extension of the independent samples t-test. In case of independent samples t-test, we can only compare the two groups, right? But when I'm having more than two groups available and I want to compare all of them simultaneously, T cannot do that. T is not having that capacity that it can compare more than two groups. So for the purpose, we are going for the ANOVA analysis or ANOVA or analysis of variance, right? So ANOVA is the extension of it, which is also means purpose is same, to find the significant mean difference, but for more than two categories, right? So ANOVA is having two varieties, one-way and two-way ANOVA. In case of one-way ANOVA, we are comparing the mean for only single, we are comparing the mean for according to only single categorical variable, right? Means I will be having only one categorical variable with minimum 3 categories, and I will having the one dependent variable, that is numeric variable. So I can compare that whether the mean is same for all the categories of the categorical variable or not. So it is one-way ANOVA. Two-way ANOVA is like we will be having two-way. That means two factors I will be having, or two independent variables I will be having. And for the two factors or two independent variables, I want to see whether there is any significant differences coming in the mean of the dependent variable or not. So in the two-way ANOVA also we are having further classification named as replication without replication. So in the case of with replication or in case of replication, that means where I am replicating or repeating my categories of one of the categorical variables, I'll go for that, right? I'll go for the replication case. And in that case, I need to formulate total 3 null hypotheses. That is, 2 will be for the main effect and one will be for the interaction effect. So that means in all the 3 hypotheses, your dependent variable will be always common. That is, numeric variable will be always common. And then you need to see the combination you need to make of your dependent variable with both the categorical variable. And lastly, for the third hypothesis, you will combine your both the independent variables or categorical variables, and you want to see whether these two combinedly impacting your dependent variable or not. Further, I'll talk about the without replication case, where I told you the difference is coming. That means you're not replicating your categorical variable at all. So that way you will go for only looking for the main effects. And we will formulate only 2 null hypotheses there, right? So friends, I think this was the agenda of the day. Today I tried to deliver to you, explain to you. Tomorrow we are going to talk about the correlation and regression, and if time permits, I'll take some of the situations where I'm expecting from the group of you that you need to understand the situation and you need to suggest me in that condition which particular test I can apply on. That will be the application part of the whole 5 days what we have learned, right? So now I think session is open for questions and answer if you are having any.
Hello, ma'am. I have one question.
Yeah.
Regarding yesterday's session. It was the t-test that we studied yesterday. In the t-test, we have always considered two-tailed analysis and p-value of two-tailed one. I wanted to know how we can interpret p-value of one-tailed t-test.
Okay. It is depending depending upon whether you have formulated your hypothesis for one tail or two tails. So I think you are knowing what is one tail and two tail. So if you are going for two tail, you will generally keep your alpha value whatever it is. It is suppose you have 5%, so you will keep it as 0.05, right? But if it is for one tail, so you will divide it by the two. So now for the one tail, it will become 0.025.
Yes, but if I mean we are formulating hypothesis as there is no difference between mean values, and but if we are formulating alternative hypothesis that there is different significant difference, and I mean it is positively it increases values or decreases,
So
then
when you
there
are
will be
mentioning the direction, ma'am, that is positive and negative, that is one tailed.
okay, and for that we have to do some different t-test in Excel.
No, I think output is giving you one tail and two tail, both the p values it is providing you.
So
I
on the
think
basis,
it is already providing you. Usually, what I am doing means I am not going for formulating the one tail or two tail. I generally write my hypothesis in whatever fashion I am writing here. On the basis of the results, then further I am concluding whether there is a positive or negative things are coming.
okay, so if one-tailed analysis shows some variation, I mean zero values, then we will reject the hypothesis and we can say that there is positive difference. I mean, values are increased in for one
P
tail.
value rule always will remain same, whether it is for the one tail or two tail. According to the p value results, if you are rejecting your null hypothesis and if you have formulated your hypothesis for the one tail, so that means accordingly you will say it's a positive or negative relationship.
Thank you, ma'am.
Yeah, thank you, ma'am. Yes.
Ma'am, I have a problem. Actually, like I have calculated environmental, social, and economic sustainability score from the sustainability report for different companies, right? And the selection of the companies is based on some purposive sampling criteria. But when I try to compare it industry wise, so in my sample, if I take one industry like real estate, it will have three company. If I take utility, it might have two company. If I take industry like steel or consumer goods, it might have five company. So can I compare the economic, social, and environmental score using ANOVA based on the industry? Because constituent of my sample is entirely different across different industry.
So simultaneously you're asking me or separately you're asking me?
Simultaneously ask. Suppose as one categorical variable I am taking an industry, and second I am taking economic. Second categorical variable is economic, social, and environmental score. Can I apply ANOVA over there? Because the mean, when I calculating the mean is score for different
No, I
industry,
need to understand your question first, ma'am. Means suppose how many variables you are having here?
only two categorical variable.
Which two?
One is the industry, second is the score, sustainability scores.
So the sustainability score you are taking
Differently, economic
no, I need to understand. Just a minute. So okay. So you are having just a minute. I need to open my Excel sheet. I'll write according what I'm understanding.
Either you
Right?
send your email ID, I will send you the Excel sheet.
Just a minute. Wait a minute. This is the Excel sheet I think visible to you, right?
Yes, ma'am.
Okay. Suppose I'm having industry type.
Huh.
Done. Second is
Score. Sustainability score, which is again divided into economic, social, and environmental category.
economic, social, and environment. But in this case, ma'am, score is your numeric variable.
Yes. So I will have 3 columns. One column has the environmental, second column has the social, third column has the economic score.
Okay,
In rows, I have different industry.
got
Right?
it.
But my problem is this: since if I am choosing say 9 industry or 8 industry, so if I am choosing an industry of consumer goods, in my sample there are 3 companies which are there. So my mean score will constitute of 3 companies. When I am choosing it as a say utility, my probably there would be 7 companies in my sample. So that would be the mean score of 7.
Are you performing one-way ANOVA or two-way ANOVA?
2-way ANOVA without replication.
I think it is without replication because I think this will be like this, no? The way I have written here.
Yes,
It will
yes.
be like this, right?
So my question is ki if number of companies under different industry type is different, can I use ANOVA? Will it not? Will it be a good result?
I need to try to understand. Like that means suppose this is industry 1 and suppose you are having here 3 companies, right?
Yes, yes,
Industry 2 you are having suppose 7 companies,
yes,
right? Then industry 3 suppose you are having 5 companies,
yes.
right? So that means what you have done, you have taken the total score or you have taken the average score.
Mean score, mean score.
So mean score is written. Suppose it is 4.5. Suppose it is 6. Suppose whatever. I don't know what you are having. Suppose I'm writing some figures, right?
Yes, yes, ma'am.
Okay. So you can go for two-way ANOVA. I don't think so. Any problem is here. But if you can keep or you can try to keep the number same, it will be, I think, better according to me.
Ma'am, because of the sampling choice.
Which choice of sampling? I think it is a secondary data. What is the role of sampling here?
Ma'am, actually, I was just trying to calculate the progress of Indian companies on SDG based on their sustainability report. So I have taken those report who are those company only who are consistently producing standalone sustainability report after 2016. So my sample is of 49 companies only.
And why you are going for two-way ANOVA? What was your objective?
My objective is to calculate whether all the companies are progressing on all the factor like economic, social, and environmental. There is no difference in the progress in different factors. There's no mean difference. Means if they are progressing environmentally also, equally they are progressing for socially also, equally they are progressing for economically also. There is no difference no variation in the progress between different part of the SDG, different part of the sustainability, different pillars of sustainability.
And how many industry you are taking here?
9, ma'am.
And in all the 9 industry numbers is very different.
Yeah, varying.
Varying like how means what is the proportion difference?
Ma'am, it's it start from 3 and it goes to 6.
I think it is okay, ma'am. I don't think so it will create problem.
Okay. That is what I want to ask. If I present a result like this, it won't be questionable.
I don't think so it will be. You can write it, what you have done, how many companies or for which industry you have taken. I think that you can mention. I don't think so it will create any problem.
Okay. Thank you.
Ma'am, for this ma'am's question, maybe we should do 2-factor with replication. Is that correct one, madam? If at all I also come across some similar situation, then if
Two-factor. It is
2-factor with
without
replication.
It was without replication, ma'am.
But there are 3 companies, 7 companies, and 5 companies. That is not replication, madam.
That is not replication. Yes, what is I'm just telling you. What ma'am is that in the one industry there were 3 companies. So for economic, what she has done, the 3 scores she has taken and she has taken the average of that.
Oh, okay.
Actually, I'm working on mean. I'm not working on company wise.
Yeah, and second thing is that she cannot go for the replication also, because the reason being she is having different numbers of companies in different industry. If it is constant, she can go for replication case also.
Mm-hmm.
It is also
Okay, ma'am.
right.
Yes, ma'am. Thank you, ma'am.
Thank you, ma'am. Thank you.
Thank you so much. Thank you, everyone. Any other query?
No, ma'am. Thank you.
Okay, fine. Thank you. So thank you, everyone. We are meeting one last time tomorrow in this particular FDP, and we will try to complete the correlation and regression, right?
Okay, ma'am. Thank you. Good.
Thank you so much, ma'am. Thank you, everyone. So Yoga sir, over to you. We are done for the day.
Thank you, ma'am.
Yeah. Thank you, ma'am. Thank you, everyone. Yeah.
Thank you, ma'am.
Thank you.